Here, another type of problem is given. Basically, so in the mass spectrum of these compounds, this is the peak ratio. Means the approximate ratio of the peak around m by 260. Means there is a peak. So look, I have calculated the mass from the Kendra software. Some of you are aware of this software. Some of you learn this software during your research. From software, I'm getting the look, the mass 260. It is demanding the same thing, mass is 260. So they are asking the ratio of the peak at m by z is equal to 260 and 261. Basically, there were two peak. Now we have to look for what is this 260 peak. If I say this is H20, this stand for mass 260. Just okay, yeah, just let's say their peak is 260. This is quite wrong because now we are dealing with the isotope. Basically, this is carbon. That is carbon 12C. We normally don't write, but here we are just doing it. 12 carbon C, that's why it is 260. Then what stand for? 261. The 261 mass is for, now see, this is 20, not I should not write as 20, I'll write as 1. So look, we have 20 carbon. Among 20 carbon, 1 carbon is 13C. Then mass is 1 more. And 19 carbon is 12C. Now, total 20 carbon. And here, it's H20. It looks like H2, but it's basically H20. And here the mass, as this is 1 carbon is 13C, we will have 1 mass more. This is 261. Then we can argue, sir, so what will be the, why not 262? Why not we have 2 carbon doped with, or just with 13C? Because the intensity will be very much less. Of course it is there, but we cannot see it on mass. So we have identified these two peak. That one is for 12C. All the carbon is 12C. That's why 260. 1 carbon is 13C, and it is 260. If I ask you, we have total 20 carbon. Total 20 carbon. And 1 carbon is 13C. And what is the natural abundance for 13C? The natural abundance for 13C is almost 1.1%. So just we have marked 1 carbon as 13C, but we have another 19 carbon left. So basically try to understand the things. Let's say this is the scenario. This is not 20, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have, let's say we have that system 10. So now this is 13C. One situation will arise, this will be 13C, this will be 13C, this will be 13C. So there is a possibility of all the carbon individually becoming 13C. So what is the probability? The total probability is we have 20 carbon, and of course we have almost, we have to multiply by natural abundance. That's why the true ratio will come out. It is like, so 22. It will be like 22. Okay. So the probability of becoming each carbon individually 13C for the whole 20 systems, carbon 20 system, 22. Okay. Now we are considering the system where each and every carbon is 12C as 100% intensity. So here, let's say this is the intensity, this is 100%. Let's say it is 100. Here, all the carbon is 12C. If this is 100%, we found that 22% of total of this system, there is a total 22% should have 13C as a whole. Total 22% means this carbon 13C, this carbon 13C, this carbon 13C individually. Total is 22%. So what is the ratio? This is 100 by 22 is closer to 5. Of course, that's why we are getting a ratio That is, if we think about m by z, let's say this is m by z, this is for 260, and here we will have almost these things 261, and here this is for these things. So the ratio is, this is 5:1. Here also I'm going to show you the things. If I could swing the data, you could understand. See, this is for, of course, this is the intensity. I have taken this data from software. This is m by z. So basically here C20 H10, basically 12 C20, and their corresponding mass is 260. And here the corresponding mass is C20 is 20, and here corresponding mass is 113. Okay, this 13, it will be 1, and rest it is 12 C 19 H20. So here we have mass 261. That is, look at the ratio. 3 is basically 5:1. If this is become 5, this is going to be 1. The software is predicting the same thing what we are getting. From that point of view, the software is very good also, and everyone is habituated with this software. So basically, here this problem is very similar as the first problem. I hope if this type of question asked, mainly the isotopic question that has been or is being asked,